software development security. And if this is not a strong point of yours, hopefully by the end of this, it'll at least boost you up a couple of rungs on your ladder. Usually when we develop software, the focus is on trying to come up with functionality, not security. And because of that, security is typically bolted on post facto, if at all. And because it usually is an afterthought, the functionality may be there, but we can poke holes in the integrated design and really you look at that piece of software and think maybe we should integrate security the next time that we build it. And usually now, the life cycle of security is put into agile development or Scrum methodologies. And by doing that, you try to address security issues up front rather than bolting on the solution. I've read an article some time ago that said that bolting on the solution is 10 times more costly than baking it in to the solution. So there's an old saying that I think is kind of interesting, and it was by this guy Doug Linder. He came up, said this. He said, "A good programmer is someone who always looks both ways before crossing a one-way street." Think about that for a second. And so as we go in and start to look at the whole world and the complexities within software development security, we'll talk about a whole bunch of different things. Some of the common development issues that we see, life cycle of software engineering, the different approaches to actually developing the code. We probably have heard of DevOps and DevSecOps. Yeah, those are, DevOps been around for a long time. So is DevSecOps, but I think a lot of people are just putting the security on top of it and starting to practice a lot more now. One of the biggest things about this domain is the change control and change management. That is a massive, massive deal in software engineering. Another thing that we'll talk about is security code repositories, and how do we put code into repositories? There's a whole bunch of different programming languages that are out there, and I'll enumerate through some of those different concepts. We'll talk a little bit about databases, and I'll get into just at a high level introducing some concepts with that. And then finally, from an attacker's perspective, what can they do to reverse engineer some of the things that programmers do and attack them? I think that in a high level, that's really what we're going to try to focus on. Again, many of these domains we could likely spend an entire year, definitely 6 months or a semester, going through and kind of getting into the details. Trying to get it in an hour or 2 hours. I'm just going to give you a high level. And if you have any questions, we can save them for the review or the reviews that are in the coming weeks. So let's go ahead and get started. So first and foremost, one of the things with software development security that you should probably, at least at a high level, start to look at is this idea of in your organization, what are you guys doing with software development, and what are some of the methodologies that are around it? There's a bunch of different things that can go right but also a lot of things that can go wrong. And it's not just because of, the programmer. It could be because of the requirements. It could be the way that the requirements are wording. Maybe the testing wasn't as robust as we had hoped for. Or maybe, our methodology is incorrect. And so to protect ourselves against vulnerabilities, we have to make sure that we introduce security controls into the entire system lifecycle of software development. And so we try to be methodical and come up with solutions that will meet the functional requirements, the system requirements, the timing requirements, everything that the customer is paying us to do. And one of the things that, if you haven't noticed in your walk of life, in your expertise, one of the things that really comes in handy is being able to talk and communicate. Communication is key. Most people in this business are, let me put it in here, introverts. And because of that, having something like Scrum, where you force somebody to come out of their shell for 30 seconds a day at that daily tag up, is uncomfortable, right? It's uncomfortable to see introverts who are these people are super smart, and I'm one of them as well. I mean, there's times when, I don't want to talk to anybody, but for purposes of trying to solve the overarching problem that's been placed in front of us as engineers, and in order for us to solve it, we have to work together and we got to communicate. And so that's one of the biggest problems that I've seen in the 20 plus years of developing software, building systems that talk to other systems, practicing security. It's definitely something to think about. Yeah, I would agree. What about the dumb introverted ones? Well, usually, they don't last very long. Usually, you can kind of get them out. I agree with that. If the Scrum Master isn't good, yep. We did. I was introduced to Scrum at NASA. The first one that we had was really good, and then the other one, they put us on a bigger project, and then he wasn't as good. So not only his organization skills weren't as good, but his attitude, and that means a lot whenever the Scrum Master brings the energy to the team. So let's keep on moving here and continue to talk a little bit about some of the different components. One of the key concepts, or the core concepts, that is introduced is this idea of object-oriented programming, or OOP. If you're not familiar with this, this is how most modern programming languages work. A lot of the older languages that are out there are more procedural and sequence based, where it's line 1 operates first, line 2 operates second, line 100, line 101, line 103. So it's more, functionally goes from top to bottom. With a lot of these bus programming languages, object-oriented programming, it allows us to reuse different components within the programming to make the system as a whole behave in a way that it was intended to. And when we get into object-oriented programming, those objects typically are corresponding to specific actions within that program. And because of that, an object can take on a whole bunch of different things. So inside here, some keywords that you may need to go and look up if you're not familiar with them. But these are some keywords that you may see that you may need to be familiar with. The actual message here, it is broken into 4 different parts. There's, if you just look at it, identify the recipient objects, the code, the specific code executes the recipient object, and then it specifies the code arguments and provides return values. So what does that mean? That means that typically we have some sort of request for information. The message, you're sending the request for information to a function within a piece of code, and the function then returns a value. So let me give you an example here. If I have a function and the function is, I'm going to put it into the chat. If I have a function and that function just asks a question, function, do you want to be rich? Go ahead and put your answer into the chat window here. Do you want to be rich? Well, I would think that the majority of you, it would either be true or false, right? It would be a Boolean value. You enter your name into the program, and then the program starts asking you questions. So the function of something, typically you send a message. When you send the message, then you're expecting some sort of value. And so when I'm going in and doing programming, those different ways that I interact allow me to build the case as it continues to operate. And so we have other things like methods, for instance, where we can have that similar to what I just showed in the chat window, where I execute, and the execution of the object will have the program receive a message. So I'm having the function. When I have the function will return something to me, right? And when I do that, it can be anything. It can be anything. And I think for me, the easiest way to think about this, at least for me, is everything around me, like on my desk here, or in our office, our big office here that we have at UAH. I look outside the window, all the cars in the parking lot, the trees, the power lines, the light posts, even in the parking lot, the painted lines, the different types of cars, people walking up to try not to be late to an 8:20 class here at Central Time. I think about all of these different things, the different writing utensils. I got a big old permanent marker here. I got a Sharpie or a highlighter. I have a Sharpie. I have pens. I have pencils. I have Expo markers. So all of these things are objects. Why did I say all that? Is because each one of those things that I just mentioned, I can write a program for and have that object behave in a way that it will return values to me based off of whatever message that I send to that method. And so the case of a writing utensil, for instance, we would need to to send a message to that method. The method would have built-in logic that would return something to the program that's asking the question. And so, if it's a, writing utensil, it would probably need to know, is it a pen? Is it a pencil? Is it a marker? Is it a highlighter? And then what color is it? What's the width of the tip? How much ink does it have left? And so we can start to enumerate so many different things to get those objects to behave in a way that's meaningful. And so I went through that whole enumeration because immediately I think about this right here. This is probably one of the easiest things to think of. So if I create a function or a method, and the method is this right here, function is what car do you drive? Immediately, I'm expecting a response, and in my head, before the answer, my mind's going 100 miles an hour, right? Is it a coupe? Is it a sedan? Is it a minivan? Is it a truck? Is it a motorcycle? I mean, do you even have a car? I mean, do you ride a bike? So it's immediately you start to think about some of these things, and then okay, what are some of the things that when you're out looking at CarMax, or maybe you're shopping for a new car on online, Facebook Marketplace or something like that. You're looking for how do we know? Well, the program asks us things to help to filter our results down and behave in a way that's meaningful to the user. And so from our perspective, if you drive a Porsche and you like the Panamera or the 911, then what color do you like? Do you want the regular, or do you want the turbo? Do you want it red? You want it white? You want it black? You want it silver, gray? What add-on features do you want? You want a convertible, cabriolet? So all of these different things come into play, and I know what you guys are thinking. No, Ben, I got a minivan, so just give me the Kia Sedona minivan, and that'll make me happy, as long as the windows are tinted, of course, right? And so the object that we create and the program that we create can be put and to a method in the order that it's executed by building logic and returning values to the program. And by doing that, that's the behavior of that object. We can create different classes of objects to allow us to build that object to make it more robust. And so usually with a class, or sometimes people say it's a library, you can build a bunch of different objects to give you a superset object. And so in the case of our example, a car, for instance, we can immediately, I remember I developed a website for a friend of ours a long time ago that I like nice cars, and he owned a tire shop that did nice rims, and so we would take the actual vehicle. Excuse me. We would take the vehicle. We had different colors of the vehicles, and then we had the rims and the tires, and we would put the different rims on, and we had those customized to be able to, on the screen, put them in the exact location where it needed to be for each specific car. And so if you chose one type of rim, it might be 20 inches, whereas another rim might be 24 inches. And then you start to get into low profile tires. And then, if you're into trucks, maybe you're digging your key into the side of the pretty little souped up 4-wheel drive, right? And so all of those different ideas that I just came up with right there for a car or a vehicle, each one of those could be an object that maybe we create a class that the class is called car. And so because of that, we're able to put them all together to give us this instance. And the instance means that we are actually invoking the class in our program that basically lets the class know that, hey, we're getting ready to instantiate you. Go ahead, in memory, create a container that allows us to fill that object with whatever we tell you to fill it with. And so before the program starts, the object's blank. But if Carol likes to drive fast cars, what would we do? We would pepper her in our program. As we instantiate the program, we would begin to say, here's a list of fast cars. And she would pick, her top 3 that she likes. She likes, the Porsche. She likes the Ferrari. She likes the Lambo. She likes the Maseratis. I mean, could we even put an F1 in there? You kidding me? Holy cow! So now, we got 5 cars that start to fill up her object. Now we need to know a little bit more, though. Carol, do you like to go 88 miles an hour, or do you like to go 188 miles an hour? Do you like red cars? Do you like blue cars? Do you like green cars? Do you like old muscle cars? Right? Those are all things that we need to think about whenever we're working out the instance of. And so by doing that, we can have ways that we can start to fill the glass or fill that object, and hopefully make it meaningful and building out the program. And there's a couple of other words that sometimes you see. One is the idea of cohesiveness. So that's the strength of the relationship, just like the word kind of implies. It's kind of like the glue. Is it cohesive? And so we typically will say it has high cohesion or low cohesion. So high cohesion means that it's very highly related to the object. Low cohesion means that it's not. And then we have this word down here that's called coupling. And so I always think about plumbing, because I've done some plumbing in the past, and I ain't very good at it, but I can fix a leaky sink if I need to. My big old self ain't getting under a sink anymore, so we'll just pay the $150 to get the plumber to come out. But the coupling typically is one thing that needs to go into another thing. And so if you have a piece of PVC and another piece of PVC, how do you get those two to actually fit together? Well, you have to have some sort of coupling that maybe takes the lower or the smaller PVC pipe and couples it to a larger PVC pipe, or maybe you're just looking to connect to the same size PVC pipes. you would use this thing called a coupler. And so it can either be tightly coupled. So programs can either be tightly coupled, which means that the two must go together if it's tightly coupled, just like couples in real life, right? Or it can be loosely coupled, where you don't have to necessarily have one in order for the other one to work. And so in order for that to work, there's a lot of different things that come into play. And so those are just some of the keywords that you will see whenever we start to talk about software design security and specifically how to program.